I had a ton of fun building this game. I basically took a couple models and had them play each other by guessing. One model had to guess a word that the other model thought. And then they reverse and they play during multiple rounds. And it's pretty cool the way you can build this very, very easily today. By watching this video, I want you to get a few lessons here. So number one, I'm gonna show you everything I did. I'm gonna show you every line of code so you can also do it yourself. And number two, I'm gonna show you how you can start using Llama 3, which is the latest model from Meta. I'm gonna be using a couple versions of Llama 3. One version is gonna be the 8 billion parameter model, the small one. So I'm gonna be running that from my computer. So it's gonna be local here. And that is great whenever you care about privacy, whenever you want to run one of these models without spending a ton of money in memory and stuff like that. The second model that I'm gonna be running is the Llama 3 70 billion parameters. That is the big one. I'm gonna be using Grok to do that. I'm gonna show you how to install it, how you can use it. And of course, that's gonna be running from the in the cloud, right? I'm gonna be playing Llama 3 70B against GPT-4. The results are really, really cool. I've played a bunch of rounds before and you'll see the results are super cool. And of course, one thing that I want you to see is how to use Langchain to set up all of this game. And what's really cool about Langchain is that I'm gonna be taking advantage of the transparency of using any model you want and the rest of the game will stay the same. You don't have to make any changes. So I'm gonna start by playing Llama 3 against Llama 3, then you can mix and match. You can play Llama 3 against ChatGPT-4 or ChatGPT-4 against ChatGPT 3.5 or even two ChatGPT-4s against each other. So it's a ton of fun. The code is very simple. If you really like this type of content, where I go and break down different concepts and show you the code, please consider subscribing, consider leaving a like. That tells the algorithm that I should keep creating this type of content. Anyway, without further ado, let's look at the code. Before, if you don't know how, let me show you how you can run Llama 3 from your computer. Not only Llama 3, but any other small model here. So here I have a browser with the Ollama website open. Okay, so Ollama is an application that you can run locally on your computer. It supports Windows, Linux, Mac, doesn't matter. And Ollama, it's gonna act as that a common interface that's gonna sit between your code and all of the different open source models out there. Ollama supports all sort of models, right? You see here, there is a link here that it's just models. And if you go there, you can see they support a bunch of different models. I'm gonna be using today Llama 3. So I want you to install Ollama. If you haven't already, you can download it, download the application and install it. And when you do, you're gonna get a command line that you can use. I have that already. So I'm gonna go to my terminal window and I'm gonna call Ollama here. And you're gonna see that it's gonna tell me all of the available commands that I can use. So I'm gonna do Ollama list. Let me see if I can type it correctly. Ollama list. And as you can see, this is showing me that I have two local models ready to use here on my computer. I have Llama 2, the latest version, and Llama 3 as well. Notice that Llama 3 is a little bit, larger model than Llama 2, 4.7 gigabytes instead of 3.8. And I'm gonna be using Llama 3. Just to make sure this is running, I'm gonna do Ollama, run Llama 3. And this is just going to initialize that model in memory. And then I'm gonna get a prompt and I can use this prompt to ask a question. 2 plus 2. And it says 4. Okay, so great. This is running perfectly fine. I can do the same thing with Llama 2. If you don't have a model locally, of course, when you install Ollama, you are not gonna have any models. You can just say Ollama pool, and then you can type the name of any of the models that you find on this page. Like if I go to Mistral, you can just pull Mistral, and that is just gonna download that model locally. It's pretty similar to what you would do with Docker containers. After doing that, after installing Ollama and having the model that you want to use locally, now you can use it from your source code. So let me show you here. Let me open Visual Studio Code. And this is the little game that I built. So I'm gonna go cell by cell. This is just a notebook that I created here, so it's easy to follow. I'm gonna go cell by cell and I'm gonna explain what everything does here, okay? So you sort of like understands what I did. The first line here is loading the environment variables into memory. There are two environment variables that I'm going to use in this game. And one is the API key to access OpenAI's GPT-4 model, and one is the Grok API key. And we're gonna get there as soon as we start using those models. I'm gonna show you how to get those API keys and whatnot, but just so you understand, I'm loading here the environment in memory, so those environment variables get into memory and my models can use them. That's what happened here in the first cell. In the second cell, I define my player class, and this is the bigger class that I have here. So I just created a class. I call it the player class. And this player will both act as a host, sort of like the player that thinks of the concept, the thing, and answer questions, or it can act as a regular player and starts asking the questions that needs answers for. Remember, this game is very simple. One player thinks of a concept, let's say a chair, and the other player starts asking questions. Is it a living thing? Is it a human? Is it a table? Starts asking questions until it guesses. And it has a limit of 20 questions. I initialize this with 20 questions. You can change the number if you want to, but basically that's the way the game is played, right? If one player guesses correctly, then that player gets a point. If it doesn't guess correctly, then the host gets a point. And then they flip roles. And then the other model will act as a player and the second model will act as a host. And they will go back and forth. And then at the end of the day, we can compute the points and we can see which model won. That's the whole idea here. This class, in the init function of this class, the constructor of this class, I keep an array of observations. This is going to be helpful to sort of like keep track of all of the questions that we have asked, right? So we don't want a player to be asking repeat questions, right? And we want to sort of like give all of this information to the player so the player knows, okay, how much do I know about this thing so far? That's where I'm gonna be storing those observations. Then I'm gonna have a model, so I can initialize this player with different models, with a Llama 3 model or with ChatGPT. So that's the model that's gonna do the heavy lifting, right? I have a concept here, so it's an attribute that keeps track of a concept if this player is acting as a host, and I have a history. And the whole idea with history is I don't want players to be repeating concepts. So if one player used chair as the concept, I don't want that chair to be used again. I want a different concept. I'm gonna keep track of all of the concepts so I don't repeat themselves. Then the first function is initialize host. When I start the game, I'm gonna be initializing one player as the host and the other one as the player who asks the questions. So the initialization as a host, this is what's gonna happen. There is a template here, which is my prompt. This is the prompt that I'm gonna use to generate a new concept, right? So let's see what the prompt is. It's very simple. It says, you are the host of a game where a player asks questions about a thing to guess what it is. Write the name of a thing. It must be a common object. So I'm restricting the model from not thinking about something weird, but just think about a common object. It must be a single word. So the model doesn't use something like red apple or wooden chair. No, I just want a single word, chair, apple, something simple. Do not write anything else. Only write the name of the thing with no punctuation. Here's the thing. Llama 3 tends to be a little bit verbose on my tests. So if I ask the model, think of a word, the model might tell me, oh, that sounds fun. The word will be computer. So I don't want the model to tell me all of that mambo jumbo. I want the model to go straight to the point. Tell me, computer. Don't announce that you are going to tell me a word. Just don't do that. Only write the name of the thing with no punctuation. Here is the list of things you cannot use. And then notice that I'm providing here within curly braces, history. So history is the parameter of this prompt. I'm going to have to supply the history of things that I have already used during the game, so they are not repeated. This is my prompt, and now I'm going to be using a prompt template from Langchain. And this is where I started using Langchain. So Langchain supports the ability to grab a string as a template and parameterize that string. So it's going to look for anything within curly braces, and those are going to become parameters to my prompt. In this particular prompt, history is a parameter. So I'm going to create this prompt template from the string, and then I'm going to create a chain. And this chain is basically sort of like the pipeline that Langchain is going to give me, where I want to take an input and all the way through that pipeline. So this chain will include the model, will include the prompt, the model, and then a parser to sort of like extract the output from the model. So here it is, very, very simple. Notice that I start with the prompt. That is the first component of my chain, is the prompt that I just defined. So whatever the input to this chain will be, which in this case is gonna be the history, right? I'm gonna be giving the history to this prompt. The history is gonna be injected into the prompt. So I'm gonna replace this history parameter with the full history of words that have been used already. Then the output of that prompt, which is just the text formatted, including the history, will come into the model. And the model is the property that I defined in the constructor here. So let's say that model is going to be GPT-4. Well, I'm going to get the output of the template into GPT-4 as an input. And then the output of GPT-4, which is the answer that the model provides, I'm going to get it into a parser, which is a string output parser. So Langchain defines a bunch of parsers that you can use to change, modify an input. In the case of these models, I'm going to be using the chat OpenAI model, for example, which is a chat model, and therefore the output will indicate that that answer is coming from AI or the system output. So you can get different users generating that output. In my case, I don't care about AI telling me something. I know it's gonna be coming from the model. So this string output parser will get rid of all of that information that I do not need. So basically, this is a simple chain, calling a prompt or sending a prompt, formatting it, sending it to the model and grabbing the answer and parsing out that answer. And that is what I'm going to be invoking. So now, notice that I assign to the concept the invocation of this chain. I'm going to pass a history to this chain. And that history, this name here, has to match, obviously, this name here, because that's the parameter that I created out of this template. And notice that I passed the list of, so I take this array, and I basically put it together as a string with new lines separating each word. So it's gonna come like a vertical list of words, right? So I'm passing that as the history, invoking this chain, and the output of this chain is the result of this prompt, right? So that is what's going to happen when I run this. Then I add that to the property self-concept. So self-concept now is going to become that word, let's say a chair, a pencil, whatever it is. And then I'm gonna append that to the history. So next time this code runs, the history also includes that word, so it's not repeated. And then I print out, well, the concept is self-concept. Before I keep going down, let me show you how this works. If I run this one cell down, you're gonna see that I'm just basically creating a player here, just the class, I'm initializing that class, and I'm passing Llama 3 model. And I'm gonna explain that in a second, but here I call initialize host, which is the function that we just talked about. And notice that the output is the concept is a bookshelf. Okay, that's the output. Bookshelf is the word that the model thought of. That's the random word that the model thought of. And that is what I'm printing out here. Notice how I initialize Llama 3. I use the allLlama class from Langchain. So there is Langchain community LLMs. And then I use the allLlama class. And I just need to specify Llama 3 here. I also have Llama 2 running on my computer. So if I do Llama 2 and I run this, this should initialize Llama 2 as well and give me an answer. So it's gonna take a second. The first time it has to load that memory, model in memory. So as you can see now, by using Llama 2, you can see that the concept is a pen. And I'm just calling that model. I can use here any model I want. I can initialize this player class with a GPT-4, GPT 3.5, Llama 380B, Mistral, whatever model I want, and my code stays the same. Nothing changes. And that is something beautiful that Langchain allows to do. Okay, so that's just the initialize host. So let's see sort of like the bulk of the work. I have an initialize player function as well, which the only thing that is going to do is just reset the list of observations. So every time I call initialize player, the player will clear the list of observations because of course we're just about to start a new game with a new concept and I don't want just to confuse the player. So very simple. Then I have an ask function, which is the player, the questions, how the player has to ask the questions. And I have an answer function, which is gonna be used by the host, okay, to answer a specific question as a yes or no. The template here, or the prompt, is a little bit more complex. I played a little bit with this prompt. I'm sure you can get it much, much better than what it is. This is not a big deal. It's the simplest thing that worked for me. When I'm using ChatGPT, for example, or GPT-4, or even the Llama, the big model, the Llama 70B, few words will do the trick, okay? I don't need to be that specific, and the model works very, very well. But when you're using like a smaller model, I had to specify a ton of like, please do not do this, or please be careful with that, because the model tends not to be that great at following the instructions. In any case, here is the template, very simple. You are a player in a game where you need to ask yes, no questions about a thing, and guess what it is? The thing is a common object. It is a single word. So I'm just telling the model, that sentence there is very, very important. I'm telling the model, do not start guessing complex stuff, okay? Because if I didn't do that, the model then was guessing wooden red chair. Like, no, it's just chair, right? It's just a common object and it's a single word. Here are the questions you have already asked. This is key. This is where I provide the model with all of the observations that it has already made. Because now the model can look at that and say, do I have enough information to guess what this concept thing is? So I'm gonna provide the list of observations. Just like before, observations is now a parameter that I need to supply to this template. Just like history before, very simple. You only have questions left. And this is another parameter. So one thing that I wanted to do is to inform the model how many total questions left the model has. So in case there is only one question left, I want the model to just make a guess. Do not ask another yes, no question if you only have one question left. Because if you do, you're gonna lose. You need to make a guess at that point, okay? And I specify that here in the prompt. Do not ask questions that you have already asked before. For some reason, the smaller Llama 3 tends to, from time to time, to repeat questions. So it already asked that the object is red. So it already knows it is red. And then randomly will ask again, is it a red object? Like, why are you asking the question again? Well, this here solved that problem. Only binary questions are allowed. The question must be answered with yes, no. And then I keep going and I even provide a few examples to the model of what good questions are and what bad questions are, okay? So this helped, and now the model is pretty good at asking decent questions. The code, what's important here, is that I'm gonna create a prompt just like I did before. The chain is the same chain that I used before, prompt, then model, then parser. And then I'm gonna invoke this chain with the two variables supported by this template, right? So one is the list of observations and the second one is the number of questions left. So very simple, the list of observations comes from the array that I have defined in this class, and questions left comes from this parameter that I'm gonna pass. So every time I ask the player to ask a question, I need to specify this is how many more questions you have left. So just very simple, and this is going to be the player asking a question. So if you go down, I also tried this before, you ask a question from this player and the question is it man-made? Okay, just very simple question just to test out that this works. Let's look at the host now, which is basically the answer function from the player class. So remember, answer is what the host will be doing, will be getting a question. The host knows about the object and needs to answer that question with a yes or no answer. That's it, very simple. The answer function will expect the question, will receive the question, and then the prompt is, you are the host of a game where a player asks questions about a concept, trying to guess what it is. So let's say the host thought of the word pencil. Okay, so this is, you are the host of a game where a player asks questions about a pencil, trying to guess what it is. The player has asked you the following questions, the following question, and then I'm going to provide a question. Notice now I have two parameters. I have concept that I need to provide, and I also have question that I need to provide. If the player guessed that the thing is pencil, answer with the word guessed. If the question refers to pencil, answer with the word guessed. So I'm trying to specify, please model. Anytime the other player uses the word pencil, it's probably right. Let's just call it a day. Let's say, yeah, you got it, right? Just don't be too strict about it. Notice that I'm using here the same variable concept multiple times through my template. That's great. That Langchain allows me to do that. I only need to specify concept once, but it's going to get replaced, obviously, everywhere that same variable is used. If the player did not guess, answer the question with a simple yes or no. Do not say anything else. Do not use any punctuation. I'm trying to keep this simple. So that's it. This little template is enough for the host to just determine whether a player guessed or didn't guess. My chain here is, you already know by now, it's pretty simple: prompt, model, parser. And I invoke this chain whenever you call answer. I'm going to invoke the chain, passing the concept, which is the variable that I initialize the host with, and the question provided by the other player. And the answer here will be a yes or no. As an example, if you go down here, you're going to see that I'm saying, hey, answer this particular question. Is it man-made? Right, from the concept that I had before. In this case, it's pen. I think before I had bookshelf. So this is actually answering from a bookshelf. And it's going to say, yeah, it's man-made. It's that simple. So this is the bulk of it. I have here the main structure that's going to allow me to play. I just need to set up the game right now. So I flip-flop the players and that's it. Count the score, just very simple. So let's see how I can do that. I'm gonna go down here and you get the game class, okay? And again, this game class is just gonna be simple. I'm gonna initialize the game class with two models. The model that's gonna become the first player and the model that's gonna be used by the second player, okay? So I have to initialize that. 3 rounds by default. So if you just start this game and don't specify a number of rounds, it's going to go 3 rounds. Player 1 is going to ask, and player 2 is just going to guess, and they're going to flip, and then they're going to flip again. And the number of questions, the number of total questions by default is going to be 20. Again, all of these you can change and you can create your own game. I'm going to initialize all of those variables, or all of those properties of this class using those parameters. And then there is a start function, which is the one that I'm going to call from outside. Okay, I'm going to initialize the game and then I'm going to call start. That's it. So this is what I'm going to do. I have this players dictionary, okay, and the player 0, I'm going to initialize a player class with model 1. And for player 1, I'm going to initialize a player class with model 2, right? And I'm going to, start with score 0. So both of them, the score is 0. If they win a round, they get a point. If they lose a round, they don't get points. The other player will get a point. Very simple. The host index is going to be 0. So I'm going to start with player 1 being the host. And I'm going to do this for as many rounds as we configured. So by default, 3 rounds. I'm going to go 3 rounds. So here's what I'm doing. I'm printing out round 1, player 1 is the host. That's just a little bit of information so you see what's happening on the screen. And then if host index is 0, I need to initialize the player index, like who's acting as the player. And the trick is just 1 minus host index. So when this is 0, the other one is going to be 1, right? 0, 1. And when this is 1, the other one is going to become 0. So by doing 0 and 1 minus the host index, these numbers are just going to start flipping, right? I'm having a hard time doing this. It's just, you get the idea. All right, so I initialized who the host is, who the player is, and I'm gonna call a function that's play. And I created this function here. And what this function is going to do is going to return whether the player guessed or not. So just keep that in mind. We are going to run through the play function as well. But for now, keep in mind that this function is returning true if the player guessed, or false if the player did not guess. If this function returns true, and let's see the parameters. The first parameter to the play function is the player who's acting as the host, and the second parameter is the player who's acting as the player, who's gonna be asking the questions, okay? So I pass the 2 players, and if the player guesses, then I'm gonna say, hey, player with that index guessed correctly, and I'm gonna add 1 point to the score of the player. So I'm gonna go to just this structure here, I'm gonna add 1 point. And notice that I'm doing that to the player index. And then if not, then I'm gonna add a point to the host, because the host thought of a word that the player did not guess, okay? So now if that didn't happen, well, I'm just gonna do the same thing for the host. At the end of a round, I'm just gonna flip who the host is. So now the host is 1 minus the host index. So again, from 0 is gonna go to 1, from 1 is gonna go to 0. The round is going to start again, and then I'm just gonna initialize the player index, and I'm gonna do the same thing. But now the players are gonna be flipped, right? 1 is acting as the host, 1 is acting as the player. At the end of this, when all of the rounds are done, I can just print the final score. And I can say, hey, player 1 this is the score, and player 2, this is the score. So we can see who won at the end of this. Now let's look at the play function. Again, it's very simple. The play function here, I pass the host and I pass the player. So I start by initializing the host. Remember, the initialization of the host is going to create a word, right? I'm gonna call the model that is represented by this host here. And that model is gonna think of a word. And the initialization of the player will clear the observations. So the player is ready to go. And then I'm gonna go through for all of the questions that are defined. By default, I have 20 questions. You can change that to 50, to 10, to 3, whatever. So I'm just gonna go through all of the questions, and I'm gonna say, hey, player.ask. I'm gonna tell the player, please ask a question. And I'm gonna pass the number of questions left, which is basically gonna be going down, right? It's gonna start in 20, 19, 18, etc. So please ask a question. And then I'm gonna tell the host, hey, just answer this question. And I'm gonna grab the answer here. So then you're gonna see on the screen, I'm printing out question number 1, number 2, number 3 was this question, and the answer was this answer. Okay, remember the answers are gonna be yes or no. And then I'm gonna add the observation. So I'm gonna tell the player, please add an observation to your list. This was the question you asked, and this was the answer given by the host. So the player has something to go off, right? The player can actually make a guess. When I'm done, I'm just gonna check whether or not the answer from the host contains the word guessed. Because in the prompt, I'm asking the host, please respond with the word guessed if the player answers correctly. So if that word is there, well, I'm just gonna return true. If that word is not there at the end of all of the questions, I'm just gonna return false. By the way, if this happens and there are still questions left, it doesn't matter, because I'm just breaking out of that loop, right? I'm saying, hey, yeah, so just game over. This round is over. Let's just go with true. This is everything I need to actually make this work. First, just because it takes a little bit more time, I'm gonna show you the results that I got before recording this video. Then I can play it for you so you can see it working. But here's how I initialized this. I created my game, and I'm passing model 1 is going to be OpenAI GPT-4 Turbo. That's the latest version they have. And I'm passing a temperature of 0.5. You don't need this temperature. I'm gonna get rid of it. So the code is a little bit simpler. By default, that temperature, I think, think it's going to be 0. I'm not sure if it's going to be 0. So I'm initializing model 1 with GPT-4 Turbo, and then model 2, I'm initializing it with Chat Grok. And that is the Llama 3 70B 8192 version. Let me show you this really quick, how you can actually run Grok, okay? So you're gonna go to Grok Chat. Here is where you can see what models they support. This is sort of like an interface, just like ChatGPT is. Notice the models that they support. I'm gonna be using this 70B 8192. This model is fast and it's good, but it's really fast. Look at this. I'm just gonna ask a question, like translate the phrase, thank you, into 10 different languages. That's a question that they just put in here. I'm gonna click on this, look at the speed, okay? I'm clicking there, boom, that's it. That is fast. That is really, really fast. You actually get 303 tokens per second. That is how fast this thing is. Okay, so this is awesome. Plus the model is really good. So I'm gonna be using this model here. Now, how can you do that? Well, you can just Grok API key. You can go there and then you can create your API key here. Of course, you have to sign up for Grok and do all of that good stuff. So you're gonna create an API key and you're gonna use that API key to connect to the model. How do you do that? Well, you need to specify. If you go Grok Langchain, you open that page, and that page will tell you, number one, what is the library that you have to install. By the way, I'm going to show you all of the libraries as well that you need to install. And then it's going to tell you that you need to export an environment variable called Grok API key, which is equal to your API key. I'm not going to show you my file because it has my API keys that I want to keep using, but it's that simple. The way I did it on my case, you'll notice that I have an environment file, .env file, and that file is the one that's going to be loaded by the load.env when I call it. The environment variables are defined within that env file, and they're going to be loaded in memory. You can also do what the documentation is telling you, which is simple as saying export, and then you can do Grok API key, and then you can just type your API key here, and that will also do the trick, okay? The other thing that I wanted to show you before I show you the results of the model is the requirements file. You are going to need to install Langchain, Langchain OpenAI, and Langchain Grok. By doing this, you're going to have access to everything that I'm using here. The python.env is the library that I use to load the environment variables in memory, okay? Just very simple. All right, so getting back to this, Model 1 is GPT-4 Turbo, Model 2 is Llama 3 70B. And I played for 7 rounds here just so you could see the results, and I called start, and that's it. They're gonna start playing. So the first round, player 1 is the host, so this is GPT-4. The concept was a chair, and player 2 guessed correctly. So Llama 3 guessed correctly. Then you get round 2. The concept was pencil, and player 1 guessed correctly, so that makes it 1-1. Then player 1 now is the host, and it was table, and Llama 3 did not guess correctly. Okay, so you can see here, you can actually read the questions and the answers. It did not guess correctly. So player 1 got another point. And then when player 2 was the host, the concept was a toaster, and look at this. Is it used indoors? Yes. Is it commonly found in a kitchen? Yes. Is it an appliance? Yes. GPT-4 zeroed in really, really quick. Is it a microwave? Is it an oven? Is it a toaster? Guessed. All right, so player 1 guessed correctly. And then the second one, oh, look at this. This one is interesting. Look at this one here. It says round 5, player 1 is the host. And then the concept was a book. And then the first question was, is it something you can hold in your hand? The answer was yes. And the second question was, is it man-made? And the answer was guessed. So here player 1 just gave it away, gave the victory away to player 2. That is just a prompt issue that you can fix with the prompt. But anyway, you can keep going down. Round 6, it was a kettle. Round 7, it was a spoon. The final score was 4 for player 1 and 3 from player 2. So basically ChatGPT won here. But it's just interesting that round 5 was just that big of a deal. Player 1, remember, player 1 is GPT-4. And it made a mistake there by saying yeah, you guessed what it is when it actually didn't. Like there's nothing here in the questions. There's nothing here that points at a book. So anyway, I guess that's an issue with prompts. So after doing this and after running this, let's just run this really quick. I'm going to execute all of the cells above this one here. And when I'm ready, I'm just gonna run this so you can see how cool the game plays as it is going through this. So now you can see it started with a book. Oh, this is interesting. Started with the same concept that it made a mistake before, but it did not make a mistake now, which is good. So player one is the host. The concept was a book. Okay, so this is, oh, look at this. Look at this. The same thing happened here. Is it used primarily indoors? The answer was guessed. So the same thing happened here with ChatGPT or GPT-4 giving away that victory for no reason. That's just kind of interesting. So let's see a second round. Player two is the host, is pencil. And let's see if it guesses that. Is it a whiteout? No. Is it a correction pen? No. Is it a correction tape? No. Is it a rubber eraser? No. Oh, it's gonna fail. Nope. Did not guess correctly. Let's see. Third round. Share. Is it electronic? Is it made of fabric? Okay, it's not that hard. Come on. Is it attached to a wall? Is it commonly found in a kitchen? It got lost here. This shows, by the way, beyond the problems that might have the prompt or whatnot, this shows how good humans are at this type of games and how poor these models are at this type of game. It's not even funny. Like, I'm pretty sure anyone watching this video will be able to beat a model just in this. Not only by guessing most of these common objects, but also by zeroing the actual object really, really quick, okay? All right, so let's see one more round and then we're gonna try Llama 3. This is the toaster. Look at this. Is it a toaster oven? This also is the model ignoring the prompt. I told the model in the prompt, just please, it's a single word. And it did ignore that. It's what it is. This is not, I don't think it's a pop-up toaster. It keeps sort of like this is player 2. So this is ChatGPT ignoring, or GPT-4 ignoring. Oh, at the end, it guessed it. In the question number 20, it guessed it. So this is ChatGPT ignoring, or GPT-4 ignoring my prompt. All right, so let me stop this. Let me stop this really quick. And as you can see, if you get this same thing, I'm gonna just comment this out. So to avoid my formatted to just get rid of those because they're not being used. And you can just do something like this, right? So now I'm gonna be playing Llama 3, the local version. The small version is really bad at this game, against Llama 3. So 2 Llama 3 is playing. I'm just gonna run the whole thing and that's it. The first time it's just gonna take a second to load, but after that it's gonna go quick. So the concept is a bookshelf, and now you can see the both models playing. So here is what's really, really cool here about like a conclusion out of this. So number one, prompting these models is hard. Doesn't matter how much details you add. Sometimes these models are just gonna break. Like you saw with the guest for no reason whatsoever. One model that was GPT-4 giving away a point for no reason. They can also cheat. It can also be the other way around. When one model says the concept correctly, but the host model ignores that and says, no, that's not it. So it can also cheating. I've also seen cheating here in some examples. So keep that in mind. And number two, Langchain is really cool, abstracting away the code that you're building from the actual model that you want to use. That gives you flexibility. That allows you to test your code with one model and maybe put another model in production. Let's say you want to use GPT-4 in production because it's the best model for your use case. You don't need to develop using GPT-4. You don't need to run, let's say, an end-to-end pipeline test just to make sure every component works using GPT-4. You can use a very cheap, simple model and run as many tests as you want without changing a single line of code. It's just the initialization of that model. So that will be enough to test the whole pipeline without having to pay the cost of using GPT-4, which is amazing. The other thing that obviously this is going to show you is this is just super fun, okay? So you can do a bunch of experiments here. With better prompts, I believe you can use a system like this to compare how good these models are. Obviously, you need better prompts to prevent as many mistakes or cheating as possible. But you can actually compare how good two models are just by using a simple scheme like this. So hopefully this helps. And if you like this video, please leave a like button, subscribe to my channel, and I'll see you in the next one. Bye.